So question 25 is honestly like a weird problem, right? So like in this question, you have a figure, and the area of square WXYZ is 25 centimeters squared. And the four smaller squares have sides 1 centimeter long and either parallel to or coinciding with the sides of the larger square. And in triangle ABC, AB equals AC. And when triangle ABC is folded over side BC, we know that point A coincides with O, the center of the square WXYZ. We want to know what is the area of triangle ABC in square centimeters. So this is like another like geometry problem. And I guess the idea is we first start with the first sentence. Like we take this problem step by step, right? So we know the area of WXYZ is 25 and it's a square. So this square here has area 25. So each of these lengths has side length 5, right? Just by using math. So that should be pretty helpful. And also we're also given that like the four smaller squares have sides 1 centimeter, right? So that tells us all of these like these small like four small squares, they all have side length 1. So this has length 1, 1, 1, 1. 1, 1, 1. Like all of those lengths are 1. And we know AB equals AC, right? They told us in the problem. And now they give us this kind of weird, this weird rule, this weird condition that like, if you were to fold the triangle over BC, like if you were to fold it, like if you were to imagine it was a piece of paper and you were to fold it, then this point A would meet up with this point O like that. So we need to somehow like use that piece of information, right? So let's look at what the question is asking. The question asks, what is the area of triangle ABC? So remember that the area of a triangle, right, is 1/2 times base times its height. And we can easily find the base, right? The base is pretty easy to find because if we just treat BC as the base, then like we know this entire length is 5. Like this entire length is 5. And we know this length is 1, this length is 1. So this length must be 5 minus 1 minus 1, which is 3. So we found that the base is 3. And now all we have to do is find the height. So to find the height is just like this height downward, right? So this red length. So we have to use this the condition that when it's folded over BC, point A coincides with O. We need to use that piece of information somehow. But basically what that means is like the height from O down to here, like these two red lengths must have the same length, right? Because they're just like reflections of each other. So they clearly have to have the same dimension, same lengths. So basically we just want to basically find what is that red length there. And like to do that, what we can do is we can say like, we know that the entire like long rectangle, like this entire length here, that has length 1 plus 1 plus 5, which is 7. So basically now like we want to find what is this like red length here basically, because that represents the height of the triangle. So we know that this entire length is 7, right? This length of this entire rectangle is 7. And we know that O is the center of the square, right? So like this distance here has to, if the entire side length of the square is 5, then halfway of that is going to be 5/2, right? 5/2 represents like the distance from like O to like this side, for example, since O is the center of the square. That means like this, let's like use different colors, right? Let's say that this blue length here, this blue height would just be equal to 7 minus 5/2. And that would give us 9/2. So 9/2 like represents this height down. And remember that these two triangles, like this triangle here and this triangle here, they're like congruent. They're like the same because they're just reflections over each other. They're just like mirror images. So that tells us that the height of the triangle is just going to equal 9/2. So then if we were to like just calculate it, we do 1/2 times the base, which is 3 times the height, which is 9/2. We would find that the answer would just be 27/4, which would be the answer. Yeah, so I feel like this problem, there was a lot going on in this problem, but like I think the main idea was to just like take everything step by step. Like you have we first started with the information that WXYZ is 25 centimeters squared. So we found the side length of the square, and then we used the information about 1 centimeter side lengths. And we found the base pretty easily, and we needed to find the height. So we kind of did this like weird like 7 minus 5 halves trick here to find the height, because like the two triangles we found were like reflections of each other. And we found the height was 9 halves, and then we just did math and used like the triangle area formula. Okay, so yeah, that's how you would do that problem.